James Webb Telescope terrifying discovery before Big Bang will change everything. When the James Webb Space Telescope lifts off from Cape Canaveral on December 25th, we'll enter a new age of astronomy. A decade in the making, the biggest, most costly, and most complicated telescope ever constructed will be tested and launched into orbit. With this telescope, what can we see and what can't we see? Did you think the Big Bang is one of them? Let's get down to that. Welcome to our channel where you get real updates about space and technologies. In today's video, we will be discussing James Webb Telescope's terrifying discovery before Big Bang will change everything. Don't forget to hit the like and subscribe button and also smash the bell icon so that you can be notified when we release a new video. Kindly stay tuned at the end of this video as we'll unveil the discovery. Thanks. At the time of this writing, Europe's Ariane 5 rocket in French Guiana has been loaded with the $10 billion telescope and is ready to launch it into orbit. For the thousands of scientists, engineers, managers, and support workers who have worked so hard to get the JWST to this point, the launch will be both thrilling and scary. They can count on my anxiety as head of the Space Telescope Science Institute Council, which will oversee the JWST Operations Center. After all, the JWST has great scientific promise and might provide answers to some of the most fundamental mysteries about the cosmos. A replacement for Hubble has been proposed for the enigmatic early universe JWST, but I like to think of it as a follow-up mission to the Hubble Space Telescope. After more than 3 decades of operation, Hubble has provided us with breathtaking vistas of the cosmos and dozens of scientific findings. For this reason, we hope and expect it to endure for many more years. Compared to ground-based telescopes, the 2.4 meter diameter mirror on the Hubble Space Telescope is smaller, limiting its sensitivity and capacity to view the faintest objects. Infrared light can be accessed by Hubble, but it can't get to the earliest stars and galaxies, which Hubble can't see. JWST, on the other hand, will be able to do this. It may be able to see hitherto unseen population 3 stars, stars generated from primordial material from the Big Bang. One of the JWST's key research objectives is to discover when and how the first stars were born, shortly after the Big Bang, and how they generated the building blocks of the earliest galaxies. Although scientists have a general idea of how early stars formed the elements necessary for life in modern technology, such as carbon, silicon, and gold, it's not clear how this occurred at the time. It was necessary to keep the observatory chilly to minimize unwanted background light to discover faint objects in the distant cosmos. This was an essential factor in the construction of the observatory. Observations of the first stars and galaxies will be only one of many scientific endeavors undertaken by JWST. Astronomers from all around the globe may apply for time at the observatory to conduct their study. The JWST will be able to see through the thick clouds of dust that enshroud newborn stars, which are completely opaque to visible light, by observing in the infrared range. As compared to Hubble, it will be able to view these straight into the stellar nurseries, where stars and their planetary systems are being created. The findings will provide light on formation of stars and the systems of planets that orbit them as a result of the collapse of dust and gas clouds. The ability of exoplanets. There were no known planets beyond our solar system when the earliest designs for JWST were proposed more than 20 years ago. Many additional planets in our galaxy have since been identified by scientists, exoplanets. The atmospheres of these planets will take up a considerable portion of the JWST's observation schedule. As compared to Earth-based observations, JWST's wavelength coverage is especially well tuned for investigating chemicals in extraterrestrial atmospheres and the low infrared background radiation. There are 2 options. When planets pass in front of their parent star, known as transit, the light emitted by the star dips. Preparing for and during a transit, we may analyze light, split down wavelength to discover the composition of the planet's atmosphere. Another method involves the employment of a coronagraph, a piece of specialized equipment that blocks out the star's light so the planet's atmosphere or surface may be seen directly. A planet's sustainability for life may be shown in this way, which could lead to additional research and the deployment of small space probes on the planet. An ideal outcome would be to discover an Earth-like planet, but this would need a very favorable set of conditions due to the planet's rarity in the solar neighborhood and obscurity in comparison to their parent star. It is most probable that JWST will investigate gas giants like Jupiter and Saturn, or ice giants like Uranus and Neptune in our solar system with its instruments. All of the planets in our solar system are in orbits much closer than our own, and their atmospheres are much hotter and more volatile. JWST will be able to examine our solar system in addition to worlds beyond it. The instrument's high sensitivity makes it ideal for studying comets and other ice things in the solar system's beyond reaches. They may carry clues about the origins of the Earth, notably the source of its water, which would have been bombarded by such asteroids early in its existence. JWST will also be able to examine the atmospheres and seasonal weather patterns of all of the planets beyond the Earth's orbit and the Sun. An ambitious, game-changing telescope like JWST requires detailed planning and concepts for what will be found to justify the cost. However, there will be surprises that no one could predict. Even though exoplanets were considered science fiction when Hubble began, they were one of the telescope's primary goals. Interested in what discoveries JWST will bring us? The James Webb Space Telescope's senior project scientist is Dr. John Mather. Dr. Mather and George F. Smoot of the University of California shared the 2006 Nobel Prize for Physics for their work utilizing the COBE satellite to quantify the thermal radiation from the Big Bang. The Big Bang theory is a simple one, but it is also one that is often misunderstood. Scientist and Nobel laureate Dr. John Mather addresses some frequently asked questions concerning the Big Bang and the significance of the James Webb Space Telescope in elucidating the earliest history of the cosmos. For the inexperienced, what is the Big Bang? A more accurate term for the expanding cosmos we see than Big Bang would be more accurate. We perceive a cosmos that is infinitely expanding. To communicate the concept of a firecracker bursting at a certain time and location, the phrase Big Bang is appropriate. The center of the cosmos does not exist. The Big Bang was a process taking place in time, not a single event in time. Galaxies are moving away from each other rather than toward a central point, and the heat left over from early periods is equally distributed across the cosmos. When did the universe begin? The Big Bang itself, however, is not visible to us. But with that, what are we seeing? Approximately 380,000 years after the cosmos started expanding, 13.8 billion years ago, we can perceive the heat that was there, which is what we refer to as the Big Bang. This intense heat permeates the whole cosmos. Even now, in fact, it does. Satellites created by NASA and ESA, including COBE, WMAP, and Planck, allowed us to study the universe's cosmic background radiation. There were just a few small fluctuations in temperature throughout the cosmos at this moment. There is no telling how far back in time the James Webb Telescope will be able to see. Will JWST be able to discover anything new? However, JWST will be able to view even further back than Hubble thanks to COBE, WMAP, and Planck. Not to observe the origins of the cosmos, but rather a time of the universe's history that we had never seen before. JWST was built. After the Big Bang, we are interested in seeing the earliest items to develop when the universe cooled down. It may be hundreds of millions of years later than the period COBE, WMAP, and Planck was constructed to view. We believe that the minuscule temperature fluctuations they saw were the gems from which galaxies sprang. For the most part, we don't know when or how the cosmos originally formed, stars and galaxies. That is the question we hope JWST can help us answer. The first stars and galaxies are not visible to telescope. We can only view back in time to when these things were first formed by gazing out into space at great distances. Hubble can't detect the feeble heat signals of these distant objects because it's too large and cold. The first stars to form following the Big Bang generated the chemical building blocks of life. That they have brought us to this point in time is something we are interested in learning more about. Despite our best efforts, we just do not know. All the chemical elements other than hydrogen and helium were created by the earliest stars, and they must have had an impact on our past in some manner. The only way to discover the origins of atoms and the evolution of our little planet Earth into a habitable place is to take measurements of the first events. How amazing did you think this invention is? And how long do you think it will remain in the best? Kindly comment down below. Don't forget to like and subscribe to this channel, and also hit the bell icon so that you can be notified when we release a new video. Thanks.